Hey, it's Kevin, and in this video, we want to talk about Ethernet trunking. Here's an analogy. Let's say that we have these three different VLANs represented by these different color straws. We have the HR VLAN, we'll call it the blue VLAN. We've got the research and development VLAN, maybe the purple VLAN, and we've got the guest VLAN, sort of a reddish pink VLAN. And if I want to send traffic for all of those VLANs from switch 1 to switch 2, one way to do that is to just have three separate connections, one for each VLAN. The downside with this is it's starting to consume ports on these switches just for the purpose of getting traffic from one to the other. What if we had 10 different VLANs? What if we had 30? I mean, some data centers, they have thousands of VLANs. If I have lots and lots of VLANs, it suddenly becomes impractical to give every VLAN its own inter-switch connection. The good news is we can take these different VLANs and we can logically bundle them together, and we can put them inside of what is called an Ethernet trunk, like we have here. And there are a couple of types of Ethernet trunks you might see when you're setting it up. There's an older Cisco trunking encapsulation type called ISL, Interswitch Link. Probably don't want to use that these days unless you're just trying to be backwards compatible with something. Today we're going to be using IEEE 802.1q trunking. And what .1q trunking does is it groups our VLANs into a single logical connection that we can send between our switches, only taking up one port each. So let's say that the purple VLAN is sending traffic from switch 1 to switch 2. Traffic goes into that purple VLAN. When it gets to the other end, how does switch 2 know what VLAN it belongs to? Well, most of the time with a .1q trunk, the trunking mechanism will add 4 tag bytes to each Ethernet frame. And buried inside of those tag bytes is the VLAN identifier. So let's say that the purple VLAN is VLAN 10. When it gets to the other side says, oh, that's VLAN 10 because it's purple. Now there is one exception. The exception is a native VLAN. With a .1q trunk, you designate the same VLAN on both switches as a native VLAN. It does not have any tagging at all. So if I send traffic from switch 1 to switch 2 and switch 2 gets it, it's looking for the VLAN identifier and there's none to be had coming in over this trunk port, well, it knows that it's the native VLAN, and perhaps we've assigned this to a native VLAN of 999. Again, it's important that those native VLANs match on each of our switches. But what we've accomplished is we have saved ports on our switches by letting all of our VLANs use a single port. And that's a look at Ethernet trunks.